In this video, we're going to be looking at the Hopitals rule. Okay, now one of the things that you need to understand is we're going to go back to limits. This is an application of derivatives. And why did I not cover the Hopitals rule back when we were doing limits? We did a whole section, and we even took an exam over limits. Why is it that we didn't do the Hopitals rule back in the old days? Well, in order to apply the Hopitals rule, we're going to have to know derivatives, and at the time of limits, we did not know derivatives. So now we're going to be able to use the Hopitals rule to simplify or to actually do problems that involve limits. So what's the objective for this video? You're going to evaluate limits using the Hopitals rule and distinguish between determinant and indeterminate forms. All right, those are very big fancy words. Now, what does the Hopitals rule mean? What it means is, let's pretend I have a function f of x and g of x. So I have a function on top here, which is f of x, and g of x down at the bottom, right? And we're going to get f of 0 is going to equal to 0. So we're going to actually end up getting 0 on top and 0 on the bottom. So whenever you get 0 over 0, you're going to be allowed to apply Hopitals. Okay, Hopitals. All right. Now, not only are you going to be able to apply Hopitals when you get 0 over 0, you're also going to be able to apply it when you have infinity over infinity. Okay. So, what we needed to know was, back in the old days, what would happen if I got 0 over 0? Well, if we were in the good old days and we got 0 over 0, that means that we could do one of three things, right? What were the three things that we could do? We could factor, rationalize, or multiply by the many denominators. Now, because we know that we're going to know Hopitals, we no longer need to know these three things. Okay? So, here we go. So let's look at f of x is equal to sine of x over x at x equals 0. Both sine of x is equal to 0 and x equals 0 at the given point of x equals 0. Alright, we cannot do one of the three things. On this one, we cannot factor, we cannot rationalize, we cannot do the many denominators. So not only does Hopitals help me do the stuff that we know how to do, it also helps us find stuff that we do not know how to do. Okay? So we have to be able to identify a function when it's in indeterminate form. When it's in indeterminate form, that means that our functions will be giving us 0 over 0 or infinity over infinity. That is how we determine whether it's indeterminate form or not. Now, if I get 0 over 1, that's not indeterminate form. If I get infinity over 3, that is not indeterminate form. It has to be infinity over infinity, and it has to be 0 over 0. Okay, so here it is. Here's a formal definition of Hopitals. Hopitals rule is applied when a limit results in an indeterminate form. All right. Now, remember, what's the law of limits? Whenever you see a limit, you're supposed to substitute. So I'm going to see my a, and I'm going to plug it in. So I'm really going to have f of a over g of a. Now, well, oops, that's an x, and that's supposed to be an a. F of a over g of a. And what they're going to say is, if I plug it in, I'm going to get 0 on top and 0 on the bottom. Or there's a big or right there, or I'm going to get infinity over infinity. So these are the two indeterminate forms that I'm going to have. So if that is true on this limit, okay, and as long as my functions are differentiable, okay, everywhere except at c, right? And g and the derivative of g is not equal to 0, because we don't want to divide by 0 again, unless we have 0 on top, right? That means that Hopitals says to do the following. You take the derivative of the top, you do the derivative of the bottom. You do not do the product rule. I repeat, you do not do the product rule. So you're going to do the dirt of the top, you're going to do the dirt of the bottom, and then you're going to substitute the c. And that's it. Okay? Alright, so some of you says, sir, I got to see this in action. Alright? So, let me see if I had an. Let me take you back to one that we did, right? So let's pretend I have the limit as x approaches 3 of x squared minus 9 over x minus 3. So in this problem, if I substitute my 3 in here and my 3 here, I'm going to end up with 9 minus 9 over 3 minus 3, which is 0 over 0. Now, back on the limits exam, you said, oh, if I get 0, 0, that means that I can do one of three things. I can factor, I can rationalize, or I can multiply by many denominators. So you would factor the top, and the top would be factored as x minus 3 over x plus 3. And on the bottom, I'll have x minus 3. So I'm about to get rid of that whole. And how do I get rid of that whole? Well, I just cancel it. Right, so I'm going to cancel this x minus 3 with that x minus 3. And now I apply the law of limits, which is substitute. I take my 3, plug it in, and I found out that my answer was 6. L'Hopital is saying, no. As soon as I get 0 over 0, I'm going to take the derivative of the top. So I'm going to have the limit as x approaches 3, right? And the derivative of the top is going to be 2x, and on the bottom, the derivative of x minus 3 is just a 1. And now I apply the law of limits by taking this 3 and substituting in there. And I'm going to get 2 times 3, that's going to give me 6. Holy smoly, sir. So if you like taking derivatives, L'Hopital's rule is going to help you do these limits. And now do you understand why L'Hopital's is being taught in the applications of the derivative rather than at the limits? Because you did not know how to take derivatives. So let's go back into the other 3 examples that I have, or 2 examples. So what I'm going to do is I'm going to plug in my 0, and I'm going to get 1 minus cosine of 0 over sine of 0. And the cosine of 0 is going to be 1, and the sine of 0 is 0, so that's going to give me 0 over 0. Oops, a little bell in my head is ringing. It says, oh, you can apply L'Hopital's. This one you can add factor, you can add cancel, rationalize, or multiply by many denominators. So what am I going to do? I'm going to apply L'Hopital's. The derivative of the top, the derivative of 1 is 0. The derivative of negative cosine of x is going to be sine of x. The derivative of cosine is negative, but there's a minus in the front, so it's going to be positive. Over the derivative of sine, which is cosine of x. And let's not forget that limit here in the front. Now I plug in my 0, and I'm going to get the sine of 0 over the cosine of 0. And that's going to give me the sine of 0, we said was 0, and the cosine of 0 is 1. 0 divided by 1 is 0. So my graph is going to be approaching this y coordinate when x gets closer to 0. Okay? Now, here's an interesting one. Okay? So when you look at this one, you're going to say, I have no idea how to do this one. Well, the great part is, as x is going to infinity, that means that this guy is going to go to infinity, and this one is going to go to infinity. So in reality, I have infinity over infinity, and that's going to tell me apply L'Hopital's. All right. So what is the derivative of the top? The derivative of the top is going to be 2x over e to the x, the limit as x approaches infinity. And you're going to say, wait a minute, so that did nothing. I still can't plug it in. So wait a minute. As x goes to infinity, this guy is going to infinity, and this guy is going to infinity. So I still have infinity over infinity, which tells me apply L'Hopital's again. So I'm going to have the limit as x approaches infinity of the derivative of 2x is going to be 2 over the derivative of e to the x is e to the x. Okay? Now, what about this scenario? Okay, what about this one? Now, x here is getting larger and larger and larger, so e to the something is getting larger and larger and larger. So that means that as the bottom gets larger, the whole thing gets smaller. So this guy is going to be approaching 0. So the limit is going to be 0. And that is going to be my answer. Alright? Now let's do one more. Use L'Hopital's to find the limit. So on this scenario, when I plug in a 0, I'm going to end up with a sine of 0 is going to be 0, and on the bottom I'm going to have 0 squared. That's still going to give me 0 over 0. I'm going to apply L'Hopital's. So I'm going to take the derivative of the top, which is cosine of 0 over 2x. And let's bring back that limit here in the front. Okay, now what happens? Oops, I made a mistake here. I put an x instead of a 0. So I am going to 2 times 0. That's going to give me cosine of 0. Oops, no I didn't. I put it on the wrong one. This is supposed to be an x here. cosine of x, because I'm not substituting. I'm going to use the law of limits here. So the cosine of 0 is going to be 1, and 2 times 0 is going to give me 0. So I have 1 over 0. So that means that I have undefined. Okay? So what I did is I went ahead and I graphed this function, sine of x over x squared, on my CAS prior to this. So here we go. Here's a function of sine of x over x squared, and it's asking for the limit of my function as x approaches 0 from the right side. So when I bring my CAS out, as I'm approaching 0 from the right side, where's my graph going? My graph is going up to infinity. And infinity, you got to remember, infinity is not a number, it is a location. So therefore, we're going to say that it is undefined. Now, be very careful, because sometimes they're going to try to trick you. For example, if you were to see the limit of 1 over x times ln of x, that can be changed to this. And this guy is going to infinity, and this guy is going to infinity. And you're saying, how can x go to infinity? Okay, here's the picture of ln of x. It's going up forever and ever. And here's the picture of y equals x. The picture of y equals x is going to be this picture right there. So they're both going to infinity. Okay? All right, now if you want me, I can do it. The derivative of the top, the derivative of ln of x is going to be 1 over x over the derivative of x, which is 1. And I have the limit as x approaches infinity. So that can be written as 1 over x. And let me put here the limit as x approaches infinity. That means that this guy is getting larger and larger and larger, which means that the whole thing is getting smaller. So that guy is going to go to 0. So my answer is going to be 0. Okay? Now, here's what happens to some students. Some students will look at the following problem right here, and they're going to take it and say, oh my gosh, sir, this guy is going to infinity. This guy is going to infinity. Therefore, my answer is going to be apply L'Hopital's. And guess what? What's the law of limits? The law of limits is to substitute. So I'm going to take my 0 and I'm going to plug it in. I'm going to get 0 squared minus 1 over 0 to the 4th. And that's going to give me negative 1 over 0. That did not give me 0 over 0. And it did not give me infinity over infinity. Therefore, it's not an indeterminate form. Therefore, we're going to say that the answer to this is does not exist. We do not apply L'Hopital's rule. And that is the end of the video.